Good afternoon, everybody. In today's video, we're going to go over how to model a variable pitch spring in SolidWorks. Before we begin, let's go over some quick spring nomenclature. The pitch of the spring is the displacement of one revolution of the spring. The wire diameter, lowercase d, is the cross-sectional diameter of the spring wire. D is the mean diameter of the spring. L_O is the spring free length, meaning the length of the spring when no load is applied to it. Okay, now we're ready to get started. Here we have a simple spring that I pulled out of a pen. Notice how the ends of the spring are closed, meaning they have a pitch that is just over the diameter of the wire, while the center of the spring has a much larger pitch. This is done using a variable pitch helix spiral curve in SolidWorks. Using this tool, a table can be created, such as the one shown here, which allows you to control the parameters for individual segments of the spring. Let's open up a new SolidWorks part and start modeling. We will design the spring with the parameters shown in this table here. Our first step is to create a circle on the top plane. We'll set the circle to be the mean spring diameter, which is 0.1495. And we are working in inches here. Okay. Now we'll go to the Command Manager and expand the Curves drop-down menu and select Helix under the Features tab. The Helix spiral interface opens up in the Property Manager. We'll set the Defined By drop-down to Pitch and Revolution. As I expand the menu, you'll see that we have a few more options here. We'll set the pitch to variable. This opens up the table interface. Each row of the table indicates a segment of the spring. The entered pitch value is the value of the pitch at the end of the segment. The rev, or height, depending on your settings in the Defined By drop-down, defines the position of the segment along the length of the spring. The pitch starts off at 0.0145 inches, so we will enter that. Inches. And it goes for 2 revolutions, so we will set the pitch in the second row while setting the revolution to 2. And we'll zoom in so you can see what we're working with here. The pitch then goes to 0.1 inches for the third revolution. So we will enter in 0.1, and for the revolution, 3. We want the spring to have 2 revolutions at the pitch, so we'll set the rev to 2 for the second row. Now we want to change the pitch to 0.1 inches. For the rev, we'll set it to 3 because we want the spring to reach that pitch in 1 revolution. If, for instance, we wanted the spring to gradually expand over the course of 5 revolutions, we would have set the rev value to 7 inches. Now we want the spring to have a pitch of 0.1 for a length of 7 revolutions. Now we'll transition back to the closed end on the opposite side. Oh, hold on. Excuse me, I entered the wrong value here. This should be 10. Not 7. Now we want to close the opposite end, so we'll set a transition line for 1 revolution to go back to 0.0145 inches, and we'll set that to 11. And finally, we want to do 2 revolutions at this pitch to close off the end. So we'll set it to 0.01450 and set the revolution to 13. Alright. And we'll set the start angle to 0.00 and we'll set it to clockwise for the direction of rotation. Okay, and hit the green checkbox. So now we have our spring, or the sketch for our spring anyway. Now we'll create a circular profile sweep with a diameter equal to the spring diameter, which is 0.0140 inches, and just select the sweep and hit the green checkbox. And we'll set our material to brass to match. And there you have it. Now we have our nice spring with its closed ends. This concludes our quick variable pitch spring SolidWorks tutorial. If you enjoyed this video, please be sure to hit the like button and subscribe to get notifications about future videos. And be sure to check out the other great tutorials on the Krawchuk Engineering YouTube channel.